Hello friends, so in the previous video we saw something about the log transformation, what are logs and why we use the logs. So if you have not seen that video, just refer that video, and in this video we are going to see a real world example. So this is my write-up, my own notes. So you will not find these on the internet anywhere else because I have just kept it with myself as of now. So I have taken the notes, whatever I have understood and the way I have understood it, so that I have kept it here and I am just sharing it with you over these videos. Okay. So there is a real world example that I have taken here. So here we are taking the example of a population growth of a country that we want to see over the past 100 years, that how the population has grown. Okay. So it may be that the population could have grown exponentially, right? Meaning it doubled every few years, right? This could be the possibility, right? Plotting this on a regular graph would show a steep curve, making it hard to see the early growth, right? So how much it grown earlier, if it is a exponential growth in every 2 or 3 years, or in every 10 years for say, in that case, what will happen that you will not be able to see clearly that what was the growth in the earlier years. Okay. But if you log transform the population data, you can plot it on a graph with a logarithmic scale. And how it will help? In the previous video, we saw that a logarithmic scale can be considered as a magnification glass, a magnifying glass, which shows the bigger things smaller and the smaller things bigger, right? So that way you will be able to see least difference, right? Least possible difference among the two values. So that way you will be able to identify that how much actually there was a difference, right? So that way you will be able to plot the graph in such a manner that even the earlier growth you can see, right? And based on the logarithmic values, you can take the anti-log as well. You know the anti-log. If you have studied in maths, there are two concepts, log and anti-log, right? Log means magnification glass, right? To make the bigger things smaller and the smaller things to bigger, right? But if you take the anti-log, you get the original values back. So that way, you will be able to see and you will be able to calculate what was the actual growth, right? So if you use the logarithmic scale, then it will straighten the curve, which will make it easier to see the rate of growth over the time. Okay, in essence, log transformation is a mathematical tool that can help us better understand and analyze data, especially when dealing with large numbers of exponential growth. Okay, so here, this thing we have already discussed in the previous video, like how the logs work. So I will leave this part like here. This thing I have already explained. So I'm just going to give you another example here related to the house prices. So imagine you have a data set of house prices. So you notice that a few houses are extremely expensive compared to the rest. If you see here, this is 1 lakh, 2 lakh, 3 lakh, and then this is like around 10 lakhs, and this is 1 crore, right? So you can see that this 1 crore is much larger than the others. Especially this one is really small compared to this one. So if you will plot the graph, then in that case, the value that is visible on the graph, this can dominate the value, which is 1 lakh. So if it will dominate the value 1 lakh, then what will happen? You won't be able to see that what is the relative, size difference, right? So in that, I mean, relative difference in the price, which will be, plotted as a graph, right? So you will not be able to understand that what is the real difference. But then you apply the log transformation. For that, you use the natural logarithms. So we are using the natural logarithms here on the base of 10. So if you take this one, right? So natural logarithms not on the base 10. It's basically natural logs is some on some other scale. It's not on the scale of 10. But if it was on a scale of 10, then what could be the value? The value will be 1, 2, 3, 4, 5. So here you will be able to see 5. Here you will be able to see 2 into 10 raised to the power 5, which means 10. Then you will be able to here see like 15. Here you will be able to see like 6 into, yeah, only 6. So you will be able to see 6 because there are 6 zeros only. Okay. So you will be able to see that one, 6 only. And here you will be able to see 1, 2, 3, 3, 6, only 7, right? So that way you can see that the smaller values, they have become larger, and the larger values have become smaller, right? So that way the logarithmic curve will show that how the prices are varying. What is the variation of the price when the size or the when the size increases, or when the area where the flats are there, or the houses are there, is varying, right? So based on that variation, you will be able to see that how the logarithmic curve is working. And based on the logarithmic curve, you know that a smaller value doesn't really mean that it is smaller. It may be that it could be bigger because it is a logarithmic scale, right? But again, it will give you some understanding that yes, this is how the prices are varying, right? So when the difference between the values in a data set could be very high, in that case the logarithmic scale is really useful, and that is where the logarithmic scale is used. Okay, so this is how it has been applied here. On the natural log has been applied. So 11.51, 12.21, 12.61, 13.82, and 16.12, this has been used. So you have seen that when I used the base 10, then you could have seen that here it was 5, here it was 10, here it was 15, right? But when the value increases, then it started diminishing, like it was only 6 for this value when I used base 10. But here they have taken the natural log. This example has taken the natural log. So in case of natural log, if the values are increasing, then it will also increase. But the difference between the two values will not be significant, right? Here you can see, right, like between 1 lakh and it's 1 crore. It's a vast difference. But here, if you convert into the natural log, it becomes 11.51 and it became 16.12. So there is not much difference. On a graph, if you plot the curve, you will be able to easily see that how much they differ to each other. Okay. So as you can see, the transformed values are much closer together. The large value of 1 crore is now less dominant. So it will not dominate entire data in the training set. So in essence, log transformation is a powerful tool for feature engineering that can improve the performance of your machine learning models. By understanding its principles and applying it judiciously, you can unlock the full potential of your data. All the gyan here, all the preaching here, nothing else. But I hope you have understood with the help of the example that how it works. And in the next video, we are going to see this example of using the logarithmic, values, and how we can scale up based on the logarithmic values, and how the data can be utilized, right? So to understand or to train the model, right? So this we are going to see in the next video. So I hope you could have understood this, and this is really example. This is really easy example, and this is really easy transformation. And when you should use it, that is the main thing. When you will use the log transformation, that's the main thing. Knowing about log transformation is not important. You should be able to know that, you should be able to understand that when you have to use it. That's it. Okay, so I hope you must have understood and you must have enjoyed this video. If yes, please share this with your friends. And with this, I would like to say have a nice day and bye bye.